This is our public dissemination project on fish defense, and my name is Erin.
I'm Taylor.
And I'm Nathan.
The first type of defense we are looking at is the use of spines and venom as a physical and chemical defense mechanism. The lionfish has 18 spines, 13 located in their dorsal fin, 1 in each pelvic fin, and 3 in their anal fin. The stonefish spines are located in their dorsal fin, and the scorpionfish are also located in their dorsal fin. The close relative of the stonefish is shown below and has several names, including the demon stinger, the sea goblin, and the bearded ghoul. This diagram shows the difference in each fish species spines. So there are poison glands located at the base of their spines, and the poison is released when the thin layer of skin or the integumentary sheath is torn, and the venom travels through the venom duct or the shallow channels to their predator.
So next we have slime or secretions. So first up is the hagfish. They have slimy mucus that fills the mouth and clogs gills of the predator to escape. And they actually have multiple slime glands that produce up to 5 gallons of slime. Next is the parrotfish. They actually secrete mucus from a mucus cocoon, and it's kind of like a bubble around them, as you can see on the picture. These glands are in the gill cavity, and the mucus usually prevents parasitic attacks and hides their smell when they're sleeping. It sort of like acts like a shield. Lastly, we have the blobfish, and it secretes an acid substance. It acts as a shield as well, similar to the parrotfish. It has highly harmful effects on predators, and it only turns mushy when brought to the surface, like the picture below. And that the picture above is what it looks like in the deep sea.
Okay, so our next defense is going to be swelling. So I want you to imagine that you're a predator about to take a big bite out of your favorite food and you're extremely excited, but just before you put it into your mouth, it swells up so big that you can't fit it. This is exactly what these three marine creatures love to do. The pufferfish, porcupine fish, and coffin fish are a fascinating group found in the ocean all around the world, known for their unique ability to inflate and deflate, making each one a true master of self-defense, or as I like to call it, swell defense. So to start off, we're going to have the pufferfish and porcupine fish. They're going to be a part of the tetradonoforms, which are two main families, so the smooth being the pufferfish and the spiny being the porcupine fish. So the porcupine fish is going to have its spines fully erect, both before and after swelling, where the pufferfish is going to have smooth skin when it is not swollen up, and it's going to erect its smaller spines once it has swollen. They can inflate their body several times their ordinary size by rapidly pumping both water or air into their stomach. The pufferfish feeds primarily at night and likes to hide during the day, making its swelling mechanism more of a safety net than something used often. So it's going to use it more during the nighttime if it's being attacked by those predators. However, the porcupine fish is known to have both a small case of camouflage to help it, as well as those long protruding spines, and a toxin known as the tetrodotoxin, which is a highly poisonous substance derived from a special organ in their body. It causes an extremely unpleasant taste for the predators, whereas with the coffin fish, it's going to be a little bit different. It's going to be related to the anglerfish, and it's going to inflate its gill chambers, but in a different way. So when the coffin fish inflates, it's going to be holding its breath. It's the only fish known to actually do this. It can hold its breath up to 4 minutes, which works extremely well for its low resource environment, helping it conserve energy. It cannot maintain its inflated shape like the pufferfish or porcupine fish when it gets bitten due to how low it in its environment it lives. This inflation helps them detect and sense predators based on sensory canals within their facial structure.
So now we're going to be talking about electricity. So first up we have electric rays. The electric muscular organ varies by the species. They unleash electric jolts around their surroundings without physical contact, and this can be up to 8 to 220 volts of electricity. Next we have electric eels. They produce short electric pulses to paralyze their prey, and this is called the leap and shock method to escape predators as well, and this could be up to 600 volts. And their electric organs actually take up 80% of their body. Lastly, we have the electric stargazer. So their organ is located behind their eyes, and they also use a similar leap and shock method, and theirs is up to 60 volts.
Now we're going to do a quiz on the fish species that we just learned about and their defensive mechanisms. This question comes from one of my favorite shows called Tanked. Which of the following fish has a poison that is 1,200 times more toxic and deadly than cyanide? For those of you who don't know what cyanide is, it is a reactive chemical compound used as rat poison and a retired warfare weapon. The correct answer is porcupine fish. They produce a poison called tetrodotoxin in their organs and skin. This poison has two defensive functions. Its foul taste can deter predators from eating them entirely, and the toxic nature of the poison can make predators sick or even die, which would prevent them from trying to eat another porcupine fish in the future.
So now for our next activity, we're going to play a little game of hide and seek, or I Spy. There are two stonefish hidden in plain sight on these reef beds. Can you spot them? And then, alright, so if you happen to spot these guys, they're actually going to be right here in the center of both pictures. So stonefish have this unique camouflage similar to a lot of the fish species that we talked about throughout this slide. A lot of these creatures are going to be ambush predators, so they're going to use either their spines, that electricity, or that swelling to kind of help them with this camouflage advantage.
The next question is, which defense does this fish use? Venomous spines, swelling, slime, or electricity? If you guessed electricity, you are correct. The picture of the fish on the slide is an electric ray. And to recap what we mentioned earlier in the presentation, electric rays produce an electric jolt in their surroundings without any physical contact to get away from predators. It also varies where their electric organ is located. Some have it on the head and some have it under their skin on the body.